So going over to Canvas, we are on the 3.2 visualizations page. And the first thing that we're going to do is download the starter file. So if we download that guy and open that up, it should look something like this. Then we also want to go to the interactive tutorial by clicking on this link here. When you do that, it should take you to this page here. So this tutorial is going to take us into the world of ggplot2. And this is the main way that people use data visualization within R. There's several other types. We can use base R, but ggplot2 is going to be the best way, going to be the most intuitive way. And it's really good because we can learn kind of one format and apply it in lots of different areas. And when we're thinking about this visualization process, we are in kind of the latter stages of an analysis. So we would have imported the data, we would have cleaned it, we would have done some modeling, done some transformations, and then finally we're ready to visualize. That is where we are skipping to in this tutorial, is how can we take clean data and create the visuals that we want to help further our narrative. That's what we are going to study. So some readings that this corresponds to, if we take a look at the R for data science, this follows roughly the content of chapter 2, data visualization. So please refer here for more written out explanations and some different examples. As well is the ggplot2 help documentation. So very good help documentation, which includes some great cheat sheets. So definitely want to download these so that you can have them as reference when you are working through the notes and with the assignments. Prerequisites for this one, we only need to have one package installed, and that is going to be the tidyverse. So to do that, we can copy this line of code and run it in the console. That will install the package. You can also go to package, install, type in tidyverse, and install it this way. Once we have that installed, you should be good to go. We just need to load the library by running library and then the specific package, tidyverse. Once you have that, we should be good. So the goal of this is to learn all the different aspects of how to create the following two plots. So we're looking at Ball State's 2012 to 2013 basketball season, and we have a summary of their points per game and whether or not they won, they lost, and whether or not it was a home or an away game. So this first visual encodes both the location and the outcome into the data points with the color and the different shape. This is kind of overplotting. It's using too many symbols, too many different attributes for one data type, for one specific aspect of the plot. So instead, what we can do is have two separate panels. So rather than changing the shape of the point, we can have two separate panels for the home and away. This kind of cleans the plot, makes it a lot easier to read, a lot more user-friendly. And it's actually a relatively easy transition to go from this plot to this plot. So that's what we're going to learn how to do, is how we can do that within the ggplot2 framework. So the last application is going to be you recreating these plots. So the first thing that we're going to do is take a look at the data set that we're going to be using, this entire section, and that is the diamonds data from the ggplot2 package. So to take a look at the help documentation for any function or any data set, you can type question mark and then the data set or the function name into the library or into the console. That brings up the help documentation, or you can also search the function in the help page as well. And as far as the syntax goes, the syntax here, whenever I reference packages and functions from the specific packages, I'll use this syntax in the tutorial. So we'll have the package name followed by 2 colons, followed by the function name or the dataset name. So that just tells you what package it's from and then what the specific function that I'm looking for. So in order to have this function available, you need to have the package installed and the package loaded. If the package is installed but not loaded, you can still reference functions. For example, let's say I want to take a look at the Palmer penguins and the penguins data set from within that package, I can reference that using this syntax and it brings it up perfectly. But if I just look at penguins by itself, I've already loaded it before. It wouldn't have worked. So let's try the train function from the caret package. It says train is not found because it's from a package called caret. And if I want to look at train, now I have the function available. So that is how we use that syntax. So the function package name followed by the function. Next up is going to be previewing the data. So a very common way to preview the data is by running the function glimpse and then whatever data set you're looking at. So if I run glimpse and diamonds, that brings up this information. So it tells me the number of rows, the number of columns, and it gives me the column type. So DBL for double, ORD for ordered factor, and it gives me the first few observations at each column. So this is a great way to preview what the raw data is that you're going to be looking at. So now that we have an understanding of the diamonds data set, so we have a few different information. So we have the caret, how big the diamond is. We have a few different dimensions of the diamonds, the price, and a few different quality variables. So we are going to investigate this. And we're going to start from scratch. So let's learn how to build a ggplot function from scratch. And the way we're going to do that is by starting with the ggplot function. So by running ggplot, all this does is creates a blank canvas. So the blank canvas, we can't do anything from that yet, but we can give it data. So let's go ahead and give our blank canvas a data set, give this ggplot function the data that we're going to work with. When I run that, I get the same result, right? Because I haven't actually told this function to do anything yet. We just have it primed with the data. So let's actually learn how to tell it what to do. And the way we do that is with aesthetic mapping. So aesthetic mapping is all about adding layers to that canvas. And we do that with a family of functions called the geom underscore, and then whatever type of function I'm looking at specifically. So to make a scatter plot, I'm going to use geom underscore point. The type of geom that we're going to use depends on what type of plot I'm making, of course. So for a scatter plot, I'm going to use geom point. For a box plot, I'm going to use geom underscore box plot, which we will cover. And the way we do this is by specifying the x variable and the y variable for our scatter plot. So x, I'm going to make a scatter plot of caret by y equals price. So now I have the data set. I have two variables that I want to pull from, and I hope that I get a scatter plot when I run this code. But what happens? When I run this code, let me try to run it in R script here. So when I run this code, we get nothing pretty much, or you might even get an error. And that is because right now, this function doesn't know where to get these objects. It doesn't know where to get caret. It doesn't know where to get price. So instead, what we have to do is we have to tell ggplot that these functions, that these variables come from the diamonds dataset. To do that, what we have to do is wrap these variables in what's called the AES function, so for short for aesthetics. So this tells us that the caret variable is coming from the diamonds dataset, right? This is the idea of aesthetic mapping. So we're mapping the caret information to the x aesthetic and the price to the Y aesthetic. And I'm going to add a point for each observation. So when I run this code now, we get the desired result. So this is our scatter plot that we wanted. So we have to tell the variables, we have to tell ggplot where to find the variables, which data set, and to let it know that they are actually from that data set with the AES function. So here's an exercise for you to follow. So we can specify other attributes as well. So let's say I want to change the color of the points from black to, say, purple. So logically, with what we know currently, we could just try color equals purple. We'll try that. If I run this code, I get an error, right? It says purple isn't found. It's looking for a column named purple. There isn't a column named purple in the data set, so it gives me an error. This is because whenever you're working with constants, they need to be surrounded in quotes. So when we are working with constant values, right, that are not in the data, we are going to be using quotes. So a constant purple, constant color. Now let's run this and see this doesn't work as we want either. This is actually because I'm still within the AES statement. So when I'm in the AES statement, what ggplot is doing is it's going into the data set. It's looking for a column named purple. It doesn't find one, so it creates one. It creates a column named purple, gives it the entire constant value. So every single value in this purple column is the same. And then it gives it a default color, which in this case turns out to be orange, right? That's not the behavior that we wanted. And the reason is because we are still trying to specify a data-driven attribute when this is really a constant. So what we need to do is relocate where we're specifying the color. So we need to specify the color locally in the geom point outside of the AES statement. Now, when I run this, we get the desired effect. So now that the color statement is outside of the AES, ggplot knows that it's not coming from the diamonds data. This is a constant value, setting it to the value purple. And that's what we get. So working with AES and working with constants, that'll be a common theme. Eventually, we'll have some local AES statements when we're working with multiple geoms, but right now we're just starting with the basics. So next up is incorporating more variables. So not just X and Y, incorporating more variables inside of that AES function. So we have a new data set now that we're going to look at called the iris. So this is a very popular R data set, which contains information about a few different flowers, about a sample of flowers. And so what we want to do is create a scatter plot where each color is based on what species. So there's 3 different species. We want to create a scatter plot where each point is colored based on the species. So to do that, what we can do is add color equals species in our AES statement because it's data driven. So it's data driven. Species is a variable in our data, so we want to have it within the AES statement. And then we can specify that we're going to make a scatter plot with geom point. And when we run this, this is exactly what we wanted to happen. So we have a scatter plot where there's 3 different colors based on the data. We could also mix and match. So now I could add some constants. So let's say I wanted to make the points a bit bigger. I could use a constant value of 10. And let's say I wanted to change the shape to be stars rather than circles. We do that locally as constants now because they're not from the data. So that's how we're working with this AES. So here is another exercise for you to try. So next up is going to be histograms. So histograms, very common. We've covered those lots in Excel. So how are we going to make histograms in ggplot? So we know that a histogram is just a univariate plot for continuous variables. And the function that we need, very intuitive, is going to be geom histogram. So what we can do is look at the help documentation for geom histogram. This can give us a good idea of what we're going to be typing in. We can also look at a better example is geom point. This tells us the required aesthetics. So the ones in bold, for a scatter plot, I need an X and a Y. For a histogram, turns out that I only need required to have an X. So the first thing that we're going to do is specify our AES statement. We're going to make a histogram of the caret. And then I'm going to add, I forgot to mention this, but to add layers, we use the plus sign. So I'm going to add a histogram layer now, geom underscore histogram. And let's take a look at the result of that. So this is the default histogram. So there's a few different options that I have with histograms. Notice here that it says the default bins is 30. So there's a few different ways to change the bins. So I could do bins equals 15. Now I have larger bins in my histogram. I could also specify the bin width. So the scale here, 0.1, we can try that value. So two different ways to kind of mess with the visual interpretation of the histogram. And we can also work with some other aesthetics. So let's try to change the colors of the bars. So I'll try color equals purple, again in quotes because it's a constant now. If I run this, this actually just changed the outline. So for histograms and bar graphs, the color refers to the outline of the bars. To change the actual colors, we need to use the fill argument. So if I change that to fill equals red, that gives us a red histogram with purple outlines. We could also specify that fill as a data-driven argument, meaning that now it's going to be based on the species. So if I do AES, I'm going to data-driven have the species fill in the colors and add my histogram. Now it groups the histogram based on the species and gives them each a different color. So we can specify those same aesthetics either locally as constants or driven by the data. Next up is kind of polishing our plots. So the way that we add nice titles and labels is with the labs function, with the labs function. So title equals, we can type in the title that we want in quotes. To label the x-axis, we can use x equals. This is a histogram of the caret weights. And histograms are by count. When we run this, this gives us our nice labels now. So that is how we kind of polish our plots with axis labels, titles, subtitles, captions, and so on. So there is another exercise for you to try. So next up is box plots. So how do we work with box plots? Recall that box plots are a very common way to visualize the distribution of a numeric variable, but we're not looking at the raw data anymore. We are mapping summary information, and that specific summary information is the minimum, first quartile, median, third quartile, and the maximum. To give you an idea of what base R box plots look like, we could do the function box plot on my X, and that gives me the base R box plot. And just for reference, here is what a base R histogram looks like. So our ggplot looks a lot better than that. It's a lot easier to customize. But if you're just working with data really quickly, kind of get a quick idea, these base R functions are going to be good starters. But when you're actually working to make polished plots, that's when we'll switch over to ggplot. So what we can do is add our AES statement to our ggplot. So the box plot requires either an X if I want it to be a horizontal box plot, and a Y if I want it to be a vertical box plot. So I'll start it out with X equals caret, and I'll add geom underscore box plot. And I typically space out, it does this manually for you in R script or in the QMD file, but in here I'm going to space it out so that the functions arguments line up together, and then we have a tabbed for each layer. So I run this code, and this gives me my horizontal box plot. If I change the aesthetic to Y, that gives me a vertical box plot. So now try to create a vertical box plot of the sepal length with that iris dataset. We can also make comparative box plots. So comparative box plots are a way to view numeric distributions by a categorical variable. So the only thing that we have to do is add in another aesthetic. So I want the Y to be cut. So now I'm going to have box plots in the horizontal direction for each cut type of diamond. When I run this, this gives me my comparative box plots. So we could also switch the orientations, but this gives us a good interpretation of the different caret prices, caret sizes, based on the cut of the diamond. And the advantage of using comparative box plots, as we know, is we're easily able to compare the centers, the medians, and the spreads and see which ones do or do not have outliers. But when we get the big data, like this diamonds data set is, 50,000 observations, it's box plots will be maybe not the best representation because the spread decreases and decreases as we get more data. So there's going to be a lot of suspected outliers that might not really be outliers, but that's just a function of how much data that we have. So one thing to keep in mind. We can also do some more transformations and customizations to our box plot. So we can actually transform variables directly from within the AES statements. So let's say I have our box plots here, but rather than the price, I wanted to look at the log of price for some reason. I can just directly do that without having to change the original data in my AES statement. So now I'm plotting the log of price. Maybe that one doesn't make intuitive sense for us. So let's try the price in thousands of dollars. So now I'm going to be looking at the price divided by 1,000. Now I have the price in thousands of dollars. So $10,000, $15,000. That's when we would want to add a new label, price parentheses thousands of dollars, something like that. We can also, maybe I wanted to have this as a horizontal box plot. rather than changing the X and the Y, we could add a function called chord flip, which will rotate our plot. So it just rotates, flips the axes. So that is a useful function. And there's also kind of custom themes that we can use. So some good ones are theme classic. So this just changes some default attributes of that canvas and the styling. Another common one that I use a lot is theme BW. So feel free to mess around with a few of those different themes. And one more exercise for us. So that is it for part 1 of this video. We will pick up with bar graphs in the following video.